Hi, Bobby.
Hi, Aniruddhan.
So we saw some diode circuits, no?
Correct.
So why don't we look at some more?
Yeah.
Can you suggest some ideas for some simple circuits?
Yeah.
Let's not make it too
Yeah.
complicated.
So we were playing with sinusoids.
Hmm.
Let's do some DC excitation.
That is true.
Hmm.
Okay, let us do that.
Yeah.
So can you tell me? I'm going to let you drive the circuit. So you tell me what to
We
do.
will have the basic one itself: DC voltage, diode, and a resistor.
And a resistor. Okay, let's do
The
that.
same thing that we analyze for the sinusoid.
For the sinusoid,
For
we'll
DC,
do DC. Correct.
It's actually a subset, but still.
Perfect. So we'll do that. So same circuit as before, except we replace the AC source with a DC source.
Correct.
So I'll just call this Vs.
Yeah.
And this is the diode V, and this is RL.
Yeah.
Some RL.
Yeah.
Right?
And ideal diode. No?
Ideal diode. Let's start with ideal.
Yeah.
I like it.
Yeah.
Easy, no?
Yeah.
So short circuit in forward bias, open circuit in reverse bias.
Correct. Output maybe V0 will mark.
Output V0 will mark. Okay.
So let's say this Vs I can vary.
Okay.
And then I want to see what the V0 will be.
So the common way of showing something varying is with an arrow through it.
Yes.
So we'll use that terminology.
Yeah.
Okay.
So I have the option to vary from 0 to, let's say, some 5 volt.
Okay. 0 to 5 volts. So, okay. So it can be anything in between.
Yeah.
Okay.
And we have ideal diode. Let's plot V0. I mean, if x-axis may be Vs and y-axis V0.
So for every value of Vs, you want to find out the value of V0 and plot it.
Correct.
Good idea. I think we'll do that. Okay. So this is Vs and this is V0.
Yeah.
Okay. Let us start from 0 because you said 0 to 5. No?
Yeah.
Okay. So if I apply 0 volts, I'll use your idea. Remove the diode.
Yeah.
See what the voltage is.
Correct.
Right. So we'll imagine that the diode is removed.
Yeah.
So let us say the diode is gone. If this voltage is higher than this voltage, it is forward biased. If the other way, it is reverse biased.
Correct.
Right. Okay. Or more than 0 in this case because the ideal diode.
Yeah.
Right now, from what I can see, if I open circuit it seems to be exactly 0.
Yeah.
Right. So we don't know. Maybe we'll increase it slightly.
Correct.
So maybe some 0.1 volts or 0.2 volts. Then what happens? Vs comes here, no? So
it's forward
biased. So for an ideal diode, what happens is that it becomes forward biased.
So it will become a closed switch.
It will become a closed switch, and output will become equal to Vs. Okay.
So it will be a.
So Vout is equal to Vs from 0 to 5.
Yeah.
It will become a straight line
at 45 degrees.
At 45 degrees, right? Correct. So I'll show it like this. I'll draw it like this. Right?
Yeah.
So 45 degrees. And this is for ideal diode.
Yeah.
Okay.
Now the question is, if I replace the diode with practical one.
With an E voltage.
With an E voltage.
Okay. So I think if ever we need to use an exponent, very rarely, right?
Yeah.
Maybe some precision applications you might need to do it.
Correct.
Like what you are saying, no? You want to measure the temperature using, something like that, using the, measure the thermal voltage and build a temperature sensor. Maybe you might need to use the extract.
Because that comes in the exponential part.
It comes in the exponential part.
Yes.
Right? Okay. So now we will just use the idealized version of the practical diode. Okay. So now I'm going to remove these crosses. Right?
Yeah.
And I will add the, maybe we'll draw it.
We will draw, we can copy paste and then.
So we'll copy paste and then draw.
Yeah.
So this is the second case.
Yeah.
And here we'll replace it with our idealized diode, no?
Yeah.
Of the real one.
Actually, the model.
The model, right? That is better.
Approximated model.
Approximated model. And this is an ideal diode.
Yeah.
Right?
Yeah.
Okay. I'll just show it in a different color.
Yeah.
So that maybe I'll choose this color.
Yeah.
Hmm?
Yeah. Okay. So if Vs is 0, across the diode I have.
Correct. I'll do the same thing, no?
Yes.
Open circuit this.
Yeah.
Find out what voltage I have here.
Yes.
If Vs is 0, oh, the
I
cathode has plus 0.7,
yes.
anode has 0.
Yeah.
So I actually have a negative voltage.
Correct.
Reverse bias,
Reverse
no?
bias.
Definitely reverse bias.
Yeah.
Right? Shall we plot on the same curve?
Or just
New
below
one?
is also.
Just below is also okay?
Yeah.
Okay. Okay. And for this one, so you are pointing out that for 0, it is already reverse biased.
Yeah.
There it was on 0 bias.
Correct.
So now it is reverse biased, right? You're starting from there. Okay. And if I keep increasing Vs to 0.1, 0.2,
still it will be reverse
biased. I will have, minus 0.6, minus 0.5 and so on. It will become 0 bias only at Vs equal to 0.7.
Exactly.
Right? So till then it is reverse biased.
Yeah.
So there is no voltage across the resistor.
Yes. So that's 0.7 volt.
That is 0.7 volts.
Yeah.
Okay. But after 0.7 it looks exactly like that.
Then the diode is.
Actually, if I had taken this 0.7 and put it in series with they are all in one network.
That's true.
We know, you could have just realized.
That's
I could have made it a voltage source Vs minus 0.7 or rather Vs in this case, correct, right? So that would have given the job, done the job for us.
True.
Right? Okay.
In this case.
In this case, of course, not every time.
Yeah.
In this case, they are in series.
Yes.
Correct. So now it will be the same old curve that we get.
Yeah.
But looks like because it's starting at 0.7, the output can go only till 4.3 volts. So that also is different.
So when x-axis I have 5.
Yes.
Output voltage will be
4.3.
5 minus 0.7.
5 minus 0.7. Whereas here I got 5 and 5. We'll note that down also.
Yeah.
And I got 5 volts. So unfortunately we are sweeping only from 0 to 5. The top part is getting clipped off.
Yes.
Right?
Suppose if we sweep negative side,
it will just be 0.
Diode will be reverse bias.
Diode will be reverse bias. And same thing will happen here, no?
Yeah.
So here, if you go negative, it will be like this one.
Yes.
Right? So I think that part is correct.
Yes.
So and then here again, it will go like this.
Yes.
No problem.
Yeah. Maybe ideally we should have discussed this first before applying sine wave, I think.
Correct. This seems like a little bit easier to understand in many ways.
But this now gives more clarity.
Correct.
Yeah.
That is correct.
Yeah.
What shall we do next?
Now I am thinking, suppose if we keep these diodes, I mean, one thing, this 0.7 is provided by the diode itself. I mean, it's
correct. It's inbuilt into the diode, no, in some way.
But if I want, let's say, this 0.7 to happen at some other voltage, let's say 1.7, I want.
Okay.
Then we can introduce a voltage source there and then rearrange also.
Absolutely. That's true. Shall we draw that?
Yeah.
Let's draw that. So I'll paste the same circuit. But okay, so let's do one thing. I will not paste this circuit, we'll paste this circuit. This is the one that we want.
Yeah.
And you want to add another 0.7, right?
Yeah.
So,
or another one.
Another one, no, not 0.7. You want to add some other voltage.
Yeah.
I don't know what it is.
Because this 0.7 anyway, it's there with the diode.
Correct. That's somehow inbuilt, no?
Yeah.
Okay. So let's choose this color. So now I'll show like this.
Yeah.
And depends on whether you want to shift it to the right or left. Let's say we want to shift it to the right. So I'll show the polarity like that.
Yeah.
Like that.
Correct. Yeah.
And I will call this some What variable shall we use? Some delta V or just
or some VB.
VB. Correct.
It's like a battery we have kept
Like a
additionally.
battery.
Yeah.
We'll call it VB. So then what
Hmm.
you are pointing out is that just like this originally, it's like adding a higher knee voltage.
Correct.
Right? So we will. So now this curve will.
Yeah.
Right?
Yeah.
And then after this, it will go at 45 degrees.
Yeah. Yeah.
Okay.
And Vout will be this Vs minus VB plus 0.7.
VB
no?
plus 0.7. Correct. That's right. And the negative will go like this.
Yeah. We will remove that diode cut there.
Correct. That's important. We should not leave that there.
Yeah.
So even the previous one, I'll just remove it.
Yeah.
Because
We
not
used
good
it
to
for
leave it. We use it for
explanation.
explanation, but we shouldn't leave it there. Correct.
Yeah.
And I'll remove this also.
So the latest one, next page, as you said, if VB is minus 0.7,
I'll make it look like an ideal diode.
then it becomes the ideal diode.
Correct.
That's true.
So if VB is minus 0.7, it will just move to the origin.
Correct.
It will look like an ideal diode.
Correct.